Yo, what up, everybody? Today we're going to be talking about interpreting a position versus time graph. And position versus time graph can tell you a lot more than just position and time if you know how to read it. So in this video, I'm going to tell you everything you need to know about reading a position time graph and how to find not just the position, but the displacement, distance, and velocity as well. So please stay tuned for the whole video, and we'll make you an expert in this. So first of all, position. Position, remember, is where something is compared to the 0 point. And the position is easily read from a position time graph because it's on the vertical axis up here. All right, that's what these numbers are. The numbers down here are the time. All right, so if I ask you what's the position at 2 seconds, you just look for the 2 in the time. There's a dot, and it's at 10, obviously. All right, so we're going to follow along on this graph and see how the position changes, but we also brought along Sir Cockroach here, who's going to show us what this motion looks like. Remember, a position versus time graph will show motion, and it's good to get a picture of what the motion looks like. So see here, this is going up. That means he's going forward. Then it gets flat right here, which means as time goes forward, he stays in the same place. Then on this downward slide here, it means he's going backwards, and he goes all the way to 0. So past where he started, all the way to 0. Now, how do you find displacement from a position versus time graph, right? The numbers on the vertical axis tell you position. They don't necessarily tell you displacement. Displacement is how far you are away from where you started, and it's found by looking at your final position minus your initial position. So if I ask you, what is the displacement at 2 seconds? You would first find your position at 2 seconds, which is 10 meters. But then you would subtract the starting position, right? Final minus initial, 10 minus 6. So your displacement there is 4. Okay, a positive 4 meaning this thing has moved 4 meters forward from where it started. At 4 seconds, you would find the position at 4, which is now 12, and you would subtract your starting position again. So final minus initial, 12 minus 6 is equal to 6 meters. At 8 seconds, you're back at 6 meters, and so 6 minus 6 is 0. So because you're back where, the thing is back where it started, and so its displacement is 0, even though it's moved forward and backwards in between. With displacement, we only care about where it is now compared to where it started. And then at 10 seconds, you're actually going to have a negative displacement because your position is now 0 and you started at 6. So you're 6 meters behind where you started. When we're looking at one-dimension motion, which is what we're doing now, 6 meters behind is a minus 6. So your displacement is minus 6. And that's how you find displacement. And so this kind of makes sense because if you remember seeing his motion, he started at 0, and at 10, he's back here. And so the difference between this and this is a minus 6. You'd have to move him 6 meters to the left to get him where he ended up. Finding distance. Finding distance from a position versus time graph requires you to ask yourself, how far did the thing move? Right? Distance is not displacement. Sometimes they're the same number, but oftentimes they're not. So how do you find distance? Well, if you have a position versus time graph that has multiple segments, right, like it changes directions, then you have to find out how far the thing moved in each of those segments. So we have 3 different segments. For this first one, when he was moving forward, he goes from 6 to 12. Right, so how far did it move during that time? It moved 6 meters. During the next segment, it's flatline. A flatline on position time graph means that it didn't move. It started at 12 here, it ended at 12 at 6 seconds. So during that time, he didn't move, so the how far is 0. Okay, we're going to keep track of these numbers when we find them. Then finally, he went from 12 meters back down to 0 meters. Now, I know he's going the negative direction, but with distance, we only care about how far, so we don't care about positive or negative, because positive and negative are just a forward and backwards direction. So from 6 seconds to 10 seconds, his distance was 12 meters, right? And so we're going to keep track of that. We have 3 different distances. We're just going to add them together. 6 plus 0 plus 12 is 18. So the distance is 18 meters. And so that's how you'd find distance. At any point, you would just add up the distance traveled for each of the segments that are given you. And this makes sense because if you watched his motion, he went from 6 to 12, which is 6 meters. Then he went backwards 12 meters. So if you add that together, it's 18 meters. How do you find velocity from a position versus time graph? Velocity is found by the slope of a line, and velocity includes both speed and direction, right? And so it can be positive or negative, because positive, negative is just a direction. If it's going forward, positive. If it's going backwards, negative. So velocity is equal to the slope of the line. If in slope, if you remember from your math days, was just the rise over the run. How much did the line go up divided by how much did it go across? Now, why does it equal slope? We're doing a whole another video on that, so you can check that out in the link. But let's jump into finding the velocity from this position time graph. So at 2 seconds, you just go here, and this time you're looking at what part of the line it's on. Okay, and you see it's on this line right here. And so you're going to find the slope of this line. Wherever that dot lands on, look at, there should be a straight line, and wherever that straight line is, that's where you're going to find the slope. And the velocity is going to be the same anywhere on this straight line. So whether we find it at 1 second or 2 seconds or even 2.3 seconds, it's going to be the same velocity, and it's going to be equal to the slope of this line. Okay, so you notice this line has a rise of 6 because it starts at 6 and goes up to 12. Has a run of 3 because it changes into a flat line here at 3 seconds. In between, it looks like it's about 3 seconds. We're going to say 3 seconds. Rise over run will tell you our slope. So 6 over 3 is equal to 2. And what that means is the velocity of this object was 2 between 0 and 3 seconds. So how fast was it going at 1 second? It was going 2 meters per second. At 2 seconds, it was going 2 meters per second. At 2.179 whatever, it's going 2 meters per second. It's going to go 2 meters per second until it gets here, and then it changes velocity. So some people would like to put this on a velocity time graph, and the way you do that is, you notice this lasted for 3 seconds, and it was a velocity of 2. You just have a flat line here. Now let's look at, any time the slope changes, we have to find a new slope. So let's look at 4 seconds, which is on this flat line. And the slope here is just 0 over 3, because rise is 0 for a flat line. And 0 over 3 is 0, which means the velocity was 0. Okay, and as we said earlier, he's not moving at this point, so that makes sense. So the velocity will be 0 until it changes right here at 6 seconds. Okay, so that's why you have a 0 velocity here. Now for the third part of this position time graph, it's sloping downward. Downward does mean we're going to see a negative velocity, okay, because it's moving in the negative direction, and so we call that a negative velocity. The rise is negative 12. So when we look vertically, if it from left to right it goes down, we assign a negative number to the rise. Its run is 4. It goes from 6 seconds to 10 seconds. Rise over run, minus 12 divided by 4 will be a velocity of minus 3. Okay, so we have a velocity of minus 3 for the final 4 seconds, and that's our velocity time graph. And so you can see here we're able to find the velocity anywhere on the position versus time graph. While it's going forward, we had a positive velocity. While it was flat, we had a 0 velocity. While it was going down, we had a negative velocity. Right? And so and we're able to find out what those numbers were by finding the velocity. by finding the slope of this line. And we're able to find out what these numbers were by finding the slope of this line. All right, so that's how you can find the velocity from a position versus time graph. Hope this video helped you all, and we'll see you in another video.